Now let's look at question 6, and before I get to the actual question, there's a couple of things to note. First, this part says spend about 25 minutes on this part of the exam. Now the free response portion of the test uh, it covers 90 minutes. You can allot those 90 minutes however you want, but the College Board recommends that you spend 25 minutes on this last question and the remaining time on questions 1 through 5. And this question is 25% of this of the score. Basically, it counts. It's more heavily weighted, so it's usually a longer question, more involved, more parts, and obviously it takes more time than the other free response questions. Even though there's more parts, frequently those parts are going to be continuation questions, but if you miss one part and you make up that answer or you get that answer wrong, but you continue with that line of thought, you can still get full marks on the following portions of that question. So let's look at it. We've got a question off the U.S. history test. Here's the question. They tell you what the right answer is, so you don't spend too long really worrying about the question. This isn't a history test, it's a stat test. So who cares what the question actually is? We can talk about it on a different time. We do see that we had a random sample of a lot of students, 9,600 of them, and they ask if 28% got it right, find a 99% confidence interval for P. And so when we go through that, I chose to copy this question or this answer off the rubric. So we'll just go through it this way. It's a little easier than typing this particular one. First of all, what I want to do is a one sample Z interval for proportion. So they like that you've stated that and that you've defined your terms. The conditions are twofold. One, that we've got a random sample from the population, and two, that I see at least 10 successes and 10 failures, or 10 students who get it right and 10 who get it wrong. And they've checked that. They've actually checked those numbers and see they're obviously both much larger than 10. Then it says let's make a 99% interval. They've written the equation down, substituted in 2.576 for their Z-star critical value. You can get that off of, I think, most easily off of the T-chart by looking down at the bottom with the 99%. And they've plugged in the values to come up with this interval. Then, of course, they wrote a conclusion in context. We're 99% confident that the true population proportion of all 12th grade students in U.S. history who would answer this question correctly is between this and this. Don't forget to do that conclusion. So there's part A, and you can pause this if you need to write something down. B says here is a tree diagram, and let's see if you can fill in the blanks. So I'm going to see if I can make my tree diagram a little smaller. So that we can see it. All right. If the probability that you get it right is, or that you know the answer is K, then the probability that you don't know the answer would be 1 minus K. They told me if you knew the answer, you're going to have a 100% chance of getting it right, which is a little bit overstated because we know that sometimes you know the answer and your humanity kicks in and you bubble the wrong thing, but that's not in this case. So down here, if we don't know the answer, you're going to totally guess. There were 4 choices, so the probability you guess correctly is 25%, and the probability you guess incorrectly is 75%. On the AP test, you should guess, if you don't know, 5 choices, so it's not quite the same, but you get the idea. And then to finish this tree, you're going to multiply down, so this is 0.25 times 1 minus K. Not very good with this mouse. And this is going to be 0.75 times 1 minus K. And so there's part B, where I filled in the chart. Okay, part C then says, based on this, so there's basically two ways you can get a question right. You can know the question and get it right, or you can not know the question and guess it right. So it looks like this. And so what that is going to be then is, we said the probability you know it and get it right is k, or k times 1, plus the probability that you don't know it, but you guess correctly, and that's what we wrote. Uh-oh. There it is. That's what we wrote right here, 0.25 times 1 minus k. So 0.25 times 1 minus k, and then it's simply a matter of distributing and combining like terms and all that business. So that's going to be k plus 0.25 minus 0.25k, which is 0.75k plus 0.25. And you could write that in a bunch of different forms, however you wanted to write it. That wouldn't matter. 0.75k plus 0.25. And then D is really the crowning jewel. Use your interval from part A and your answer from C. So there's your clue. You better use both those parts, part A and part C, to calculate and interpret a 99% confidence interval for K, the proportion of all U.S. 12th grade students who actually know the answer. Now, what we did on part A was we found the percent who actually got it right. Now we want to find the probability they actually know the answer. And it says here that we don't need to check conditions again. So this perhaps is not as strange as it sounds. Back on part A, we got an interval of 0.268 and 0.292. Is that right? 268 and 292, yeah. So I'm going to just jot that down here. So from part A, I know that a 99% confidence interval is 0.268292. From part C, I believe, and we'll go back and look at part C, I believe the probability you get it right is this. And remember, K was the probability you actually knew it. So I'll even copy it. I believe the probability you get it right is this. And so now I'm just going to simply equate those. Now I can simply equate this with the endpoints of my interval. So I go that equals that, and I'll scoot over here, or that equals this. Let me make this a little bigger. And so if I know the 99% interval is this interval, and I believe that the way to write that using the variable for what percent you know, or what percent knows the question, is this, I'm simply going to solve these two intervals, or solve these two equations to find my new endpoints. And so when I do that, this one is K equals 0.024, and this one is K equals 0.056. So I am 99% confident that the actual proportion of U.S. 12th grade students who know the answer to this question is between that and that. Now this should make sense to you if you think about it, because we knew from the beginning that 28% of the students got the answer correct. But we also know that if there's only 4 choices, there's a 25% chance that you'll get it correct simply by randomly guessing. And so students on this question only did very slightly better than that. And that better than that, or that improvement, is represented or represents the students who actually know the answer. Since we only saw a very small improvement over random guessing, it's reasonable that a very small proportion of students actually knew the answer to that question. Looking at some problems that we'd see, I think, is that the last part? Yeah. Looking at some problems we'd see on this question. The average grade was 1.31. Now remember, this question counts basically double, so we want to make sure that we spend some time on it and that you get some good points on it. Number of students didn't state what kind of test or what kind of procedure you were going to do, or you simply said something like a z-interval. They want you to say it's a z-interval for proportions. They want you to check conditions, not just state the conditions. Some students said something about the sample size being bigger than 30 or 40 or the central limits there. We really want to make sure that we have 10 successes and 10 failures. That NP idea is what's important here. Says some students reported the interval correctly but showed work that didn't match up. Yeah, because you used your calculator. Make sure those things match. Some students talked about the mean proportion. Number of students didn't put it in context, or they said confidence level instead of confidence interval. If I'm reporting the confidence level, it's because if I repeatedly sample this in 99% of the intervals that I create, I will get the true value. The interval itself means I'm pretty sure, I'm 99% sure that the true whatever is in that interval. And some students didn't recognize that they've got wrong answers like negative values or values bigger than 1, but they're for proportions. Some students use set notation for probability, like not K or K is greater than C, rather than this complement idea. Some students assumed that K was 0.28. Some students multiplied rather than added. So when you get to the end of the tree diagram, you need to add those parts. You multiply down the branches, but you'd add them at the end. Some students use poor notation like this. And then finally on part D, a lot of students didn't use their interval from part A, even though the question explicitly said, use your answer for part A. Some students revealed in their interpretations that they didn't really understand the difference between P and K. And some students made the same interpretation errors that they talked about in part A. So hopefully through this will give you some good ideas. If you want to see how you would actually score, you can find the rubric on the College Board website. You can Google it and see how they would have actually graded it. But the big idea is that you've learned some steps that you can take, some simple steps even, to improve your communication and increase the likelihood that you score well on this test.